So having talked about integer exponents, we can now talk a bit about rational exponents. In other words, exponents with fractions like 1/2 and 1/3, etc. Number one asks us it says the following equations are true, write the general rule or rules that are used in each case. So 8 square root of x to the fourth is equal to x to the 1/2. So the general rule is that the nth root of x to the m is equal to x to the m over n. So if we had the 8th root of x to the fourth, that should just be x to the 4/8. But 4 divided by 8 is 1/2, so that's x to the 1/2. The next one is the cubed root of -64 divided by the cubed root of 8. Remember that we can have a cubed root of a negative number. We just can't have a square root of a negative number. And they say this is equal to the cubed root of -8. Well, this is using the property that the radical of a divided by the radical of b is equal to the radical of a divided by b. So since -64 divided by 8 is -8, we can simplify in that way. Finally, we have the cubed root of x times the 4th root of x is equal to x to the 7/12. So first of all, we can convert these to exponent form. So x to the 1/3 and x to the 1/4. And then remember that you would add these exponents. So that would be x to the 3/12 and x to the, let's see, this is 3/12 and this is 4/12. So that ends up being x to the 7/12 using the rule that x to the m times x to the n is equal to x to the m plus n, and the rule that the nth root of x is equal to x to the 1 over n. So those are the two rules that we're using. Number 2 asks us to explain the meaning of the root of a power theorem, which says that the nth root of x all raised to the mth power is equal to the nth root of x to the mth power, which is equal to x to the m over n. So this is true if x is greater than or equal to 0. So basically what this is saying is that if you have a rational exponent, the numerator is a power and the denominator is a root, and you can either do the power and then the root, or you can do the root and then the power. It is your choice which to do first. So basically this is root, then power. This is power, then root. And this is as a rational exponent, which can sometimes be the simplest way to do it. 3 asks you to simplify a nasty McNarf of y to the 1/3, y to the -2, all divided by x to the 5/3, y cubed, all to the -3/2, all to the 3/2 power. So a few ways to do this. I'm going to try and simplify the stuff in the parentheses first and then apply it to the 3/2 power. So y to the 1/3 and y to the -2, I could add those exponents. So this is -6/3, so that should be y to the -5/3. So I'm just combining these by adding those exponents. And then down here, I can, since I have a power to a power, I can multiply these. And 5/3 times -3/2 is -5/2. So that's x to the -5/2 and y to the -9/2. And that's all to the 3/2 power. Now, I'm going to go ahead and distribute this to everything right now. So y to the -5/3 to the 3/2, I multiply and I get y to the -5/2, all divided by 3/2 times this is going to be x to the -15/4, and 3/2 to this is going to be y to the -27/4. Okay, so basically, because this is all multiplication and division, I can just do power to a power in each case. Another step I could have taken before going here is actually to write this as x to the 5/2, y to the -5/3, y to the 9/2, all to the 3/2, right? Making these exponents positive and putting them in the numerator. And I could have added these y's together if I wanted to, but I kind of don't want to because then I have to get a common denominator. So from here, I do need to simplify the y's. So I've got negative 27/4. This would be y to the negative 10/4. So if I've got negative 10, I'm going to add 27, so I should get y to the 17/4 and x to the 15/4. That would be my final simplified answer for this problem. So a lot of adding fractions, but the important rules are that if you have a to the m all raised to the nth power, you should get a to the m times n. And if you have a to the m, a to the n, you get a to the m plus n. And of course, if you have a to the m divided by a to the n, you get a to the m minus n. So those are a few of the important rules. Finally, number 4 asks us to simplify the 5th root of 32x to the 15th y to the 10th divided by z to the 25th. So we can break this up to be the 5th root of 32, the 5th root of x to the 15th, the 5th root of y to the 10th, all over the 5th root of z to the 25. That is using the properties that a radical a times a radical b is equal to radical ab, and that the radical of a divided by b is equal to the radical of a divided by the radical of b. So if you have roots with multiplication inside, you can break them up if you want. Well, the 5th root of 32 is the number that multiplies by 1 5 times to get 32, and that's 2. And then this, using the root of the power theorem, I can just do x to the 15/5, which is x cubed, y squared, all divided by z to the 5th. And that would be my simplified answer. So that is some problems involving rational exponents and the root of a power theorem.